Hello everyone and welcome to Rudy's Retro Intel. On today's show we are looking at this computer. It's the NABU personal computer and here it is. This is the unit I've got with the keyboard and we're going to fire it up and take a look and see what it can do. Oh, this doesn't look good. There is something strange happening. The video is all inverse characters. So boo to that, but don't say boo, say NABU, because I have this document I've written to help diagnostic computers. So let's peek inside and poke around. Here we have my NABU Computer Diagnostics Manual. I've written this because there's no other diagnostics manual out there for the NABU computer. There's a lot of videos out there regarding some software and some hardware additions like a floppy drive, and people are changing the ROMs and stuff on the board, but no one's actually written a diagnostics manual. Well, I have. So let's go through this real quick. This is created by me and with help from Geek With Social Skills. There's also schematics for the NABU and some technical information by a gentleman named MJP. Not sure who he is. I've also put a link to, not a link, the name of the file you can find. NABU personal computer manual and some spreadsheets. So my version, which is underneath the board, you can find the version number. This is version 1 or 01. And the document states that this diagnostics is based on what I have on my computer. Other versions might be available, I'm not sure, but if they are, then we will update this document to do diagnostics on those. So as we can see, the video problem that we're having is a video problem. We're not seeing a proper image. We should be seeing the NABU logo and a blue screen. In this case, it'd be a video. So let's look at the sections. We have the NABU configuration, location of ICs, pictorial diagnostics, complete system failure, network adapter failures, keyboard failures, sound failures, serial failure, LED failures, like there's LEDs on the front panel, system RAM failures, video failures, and this is what we want. Also have a card slot failure, the NABU schematics, locations and part numbers, NABU connector pinouts, keyboard encoder chart, NABU memory map, and then baud wires. So let's look for video RAM, which is on page 22. So let me jump there to 22. And here we see video RAM failures. So basically what you're doing is you're looking at your screen and you're matching the pictures on this document to see do they closely match to the problems that you're having. So in this case, this is not the same picture, so let's keep scrolling. Not this one, not this one, not this one, nor this one, but this one seems very similar. It's got inverse characters. The logo and text characters are not displayed correctly, inverse video bars, which is what we're getting. So according to the diagnostics, we need to replace the chip at U22, which is a TMS, it's a Texas Instruments 4116-15NL, and it's a DRAM, and it's a 16 by 1 at 150 milliseconds. I've added the Gemco part Gemco link for their parts, and I've also added the chip itself with the pinouts and what you can expect. So let's pull out the scope and check to see the pins on here and see what we're getting and get this board fixed. Okay, I've got the NABU main computer on the bench. There's 4 screws on the side. I've already pulled them off. So let's peek inside and see with the documentation if we can get this thing fixed. So let's pull this off. This just slides up and put that on the side, and we can find U22. Now this is marked U17, 18, 19, 21, 22. Oh, so we can see what the problem here is. As you can see, I forgot to put back the RAM chip, this one here. So while I was doing my testing, I actually put sockets on the video RAM. I put sockets on the memory RAM. I also socketed the keyboard controller, and I must have forgot to put this one back. So let's put this one back in here and see if we can get this thing booted up. Okay, let's power it on and go from there. Alright, everything's connected now. Let's power up the NABU and see what happens. Oh, so far so good. We're getting a proper screen. We can see the NABU logo showing, and we are not getting any other errors. We will get an adapter error because I'm not plugged into anything else at this time. And let's see if we just get the adapter error and not a video error or other errors. And there you can see we have the adapter failure, which is normal for this computer since it's not connected to anything. So with that fixed and out of the way, let's go back to the document and explore it a little bit more. Now that we're back in the documentation, I just want to quickly show you a few things. I've gone through this part. I've showed you the index. There's a couple of things, or a few things that we can repair on the board. The CPU is running at 3.58 megahertz. It's a Z80 based. Has a total of 80K, 64 is for the user, and 16K is video. Has 4 slots. You can add additional cards to it. The ROM is a 4K, and you can modify the board to run an 8K ROM. It outputs NTSC frequencies and has composite, and also has an RF modulator. The characters are in text mode is 40 characters, and the graphics, it's 24 by 40. Graphics is 32 by 24. Total screen resolution is 256 by 192 pixels, 15 colors, plus a transparent capabilities, sprite-oriented, hardware-supported animation. The keyboard uses a 10 volts unregulated power supply, which is used to power the keyboard, also to send and receive the data from the key presses via a twisted pair cable, and that runs at 6,992 baud. There's also a printer port, which is a DB15 female D-type connector, which is a standard Centronics parallel port. Audio output, it also has the adapter on the back, which is used to connect to, let's say, your computer and then to the net. It runs at full duplex. It's 111 kilobits per second serial interface. It's a serial interface. Now, this documentation, we will not be talking about any software related issues. This is only a hardware document. Now, the location of the chips. So I've outlined where all the parts are located. This is the video ROM, a video processor. This is the keyboard controller, serial controller. This is where the sound generator is, the Z80 CPU, the ROM. The system RAM is located here, and the video RAM is here. Now, the video IC, the video display, is a Texas Instruments TMS 9918A and L. The keyboard has a programmable communication interface by Rochester D8251AC. The serial/network IC is made by Western Digital. It's a universal asynchronous receiver and transmitter. The TR1863-B-02. The Z80 processor is made by Zlog. It's a Z80A. The sound IC is a programmable sound drainer by ETC, and it's the AY-3-8910. The ROM on the board is a 2732G. The memory, Texas Instruments of 4116-15. And the system memory is from Hitachi. It's HM4864P. So it's a 64 by 1 byte DRAM. And then we're talking about pictorial, how it's basically a pictorial guide. You just follow the screens and see what compares to yours and go view the symptoms and diagnostics. So in this case here, it's a black screen. It's a black screen, no sound. The alert LED is located on the front panel, which may be on. In some case, may be off. I'm not sure. But we're going to go through the diagnostics. Check you have power. Check if there's a fuse is okay. Sure the motherboard is connected to the power supply. And other issues which are power supply related will be coming in the future documents. I've also included a picture here of the power supply. So here we can see where the fuse is located. So you want to check the fuse and make sure that the motherboard connection is correct. Also, if there's a problem, we can check the cables, check the EEPROM, check the video processor and CPU. Now included are the pinouts for the video processor and the CPU. So the reason why I've added this is that if you have your oscilloscope, you can then go and probe to see what's going on to help you diagnose the problem. Because the problem may be these chips, but it might be something else. So here we have the network adapter. Also, if you are plugged into the network and you're expecting something, but you're not, there are several chips you can check, and again, pinouts. Because the issue could be in other areas, this is wise to look at the pinouts and check with your scope to determine if the problem is this actual chip and proceed from there. Then we have keyboard failures. Again, I'm supplying the chip and the pinouts for the chip. The next is sound. Here's the AY38910 and the pinouts for that. Serial failure. Again, here's a chip for the serial. The LED. Now on the front of the NABU has this section here which LEDs come on, power, pause, alert, and check. So you can, if you're not getting any LEDs lit up, you can then check again several ICs. And this is the system RAM. So as you can see, we have multiple screens in this particular case, different colors and so on. And we give you the location of where the possible IC is that's causing the problem. There may be more than one. In this case, it's only as if one IC has gone bad. But again, you have to do some more troubleshooting. And this guide is to only give you a quick guide and some guidance as to where the problems are and how to deal with them. So here we are into the video RAM section. Let's just scroll past this part. We've already looked at this one earlier in the video. And here we are with the card slot failure. So that you can see there's 4 slots, and you can add optional cards on there. If there's a problem, well then here are some possible locations of ICs to check. And again, we have pinouts provided. The next part here is the NABU Computer schematics, and really good, very nice, clear diagrams of the schematics. And this one here, we can see this is the actual slots and all the ICs and components needed for the slot. We will move forward on here and see the IC location and part number. So if you want to know what was an IC 22, which we replaced, which I added back to the board, it was U22. So U17 to U24 is the TMS 4116. So as a quick guide to show you which part number. Next we have the connectors pinouts. So there's the LED board. This has the pins and what they are corresponding signals should be. The network adapter, the power supply, the voltages you're expecting the power supply, the game ports, and the keyboard. Next we have the keyboard encoding chart and the memory map. And finally, bodge wires. So on the back of my board, when I've opened it, I saw that there's a lot of bodge wires. Not a lot, but quite a bit of bodge wires. And I took some high-res pictures, and I thought it'd be best to include them in this document. So if you do have bodge wires on yours, and they're the same layout as mine, or same revision, I guess it'd probably be the same layout, you could then use this as a reference guide if you have to remove them or they're missing. So in this case here, if you have to replace this IC, you have to take this capacitor out, you will now know where it goes back. Same thing in this images. So there are several images on here, high-res images, that will show you the bodge wires, where they're coming from, where they're going to. For example, this one here is going from this pin to this pin of these two ICs. This capacitor is between these two pins, and so on. So this will hopefully help you to ensure that your NABU bodge wires are correct. And that's the end of that document. So hopefully you enjoyed this video, and you can find the diagnostics documentation on my GitHub, also on the nabunetwork.com site, created and maintained by Geek With Social Skills. Look in the link below for his information and the link to his YouTube channel, plus link to his NABU site. So thank you for watching, and we'll talk to you later. Take care.